What's up YouTube and welcome back. In today's video we're going to start a brand new series on TryHackMe. We're going to be covering the CompTIA PenTest Plus learning path. So this is going to have 4 different modules: the penetration testing tools covering the Nmap, Burp Suite, Metasploit, Nessus, and Hydra. As you can see here, we already covered the tutorial, so if you still need to go through the tutorial, I'll post the link down below in the description. And then we have application-based vulnerabilities, HTTP in detail, OWASP top 10, OWASP Juice Shop, and Vulnerability, which we covered in the other series, the basic computer exploitation modules. Network-based vulnerabilities, which is going to be introductory to networking, network services 2, and then Kenobi, which we covered in the basic computer exploitation module series. Last module is going to be the local host vulnerabilities, covering Active Directory basics, Attactive Directory, attacking Kerberos, and post-exploitation basics. So in the CompTIA PenTest Plus learning path, this pathway allows individuals to practice the majority of practical skills required for the CompTIA PenTest Plus exam. In this, we're going to learn industry standard penetration testing tools, identifying and exploiting different network services, exploiting web applications through today's most common vulnerabilities, understanding Windows Active Directory, and attacking Kerberos, which is an authentication protocol that we'll tackle later on in the series. And then post-exploitation techniques with PowerView, Bloodhound, and Mimikatz, which are 3 different tools. And the CompTIA PenTest Plus is for cybersecurity professionals tasked with pen testing and vulnerability management. So there is a prerequisite. If you meet the prerequisites, if not, and you still feel confident in pursuing the series, go ahead and start on the Nmap room. So Nmap is going to be an in-depth look at scanning with Nmap, a powerful network scanning tool. So we'll go ahead and open that in a new tab, and then let's go ahead and deploy the machine. We're going to give this about a minute to load. Okay, now we can see that our box finally spun up, and we can tell by looking at the IP that's populated here. So I already answered this. So deploy the attached VM, complete, onto task number 2. So introduction. So I'm going to simplify this and break this down a little bit. So basically, knowledge is power in hacking. So proper enumeration of a target system or network is essential before any exploitation attempts. So port scanning is usually the first stage of enumeration to establish the network landscape, as ports are necessary to receive connections and direct traffic to the appropriate services. For example, when connecting to a web page, your computer opens a random port while the server's port is open to receive the connection. Before performing a security audit on given IPs, we must determine the services running on those targets. So this is done by port scanning, which opens ports to receive connections. Connections are made between 2 ports, an open port on the server and then a random open port on your computer. So basically, this diagram over here shows what happens when you connect to multiple websites. Your computer randomly opens up a high numbered port and has 65,535 total ports available. So standard ports include like HTTP, which is port 80, HTTPS, which is 443, and then NetBIOS, which is 139, and SMB, which is 445. Port scanning is necessary to find out which ports are open, and Nmap is the industry standard tool used by many professionals for port scanning and vulnerability scanning. So what networking constructs are used to direct traffic to the right application on a server? That will be ports. How many of these are available on any network enabled computer? It'll be 65,535. So how many of these are considered well known? These are the standard numbers mentioned in the task. So well-known ports usually go up to 1024. On to task number 3. So Nmap switches. Like most pen testing tools, Nmap is run from the terminal. There are versions available for both Windows and Linux. For this room, we'll assume that you are using Linux. However, the switches should be identical. Nmap is installed by default in both Kali and the TryHackMe attack box. So we can go ahead and open up our terminal. Right, there we go. Go ahead and zoom in. What is the first switch listed in the help menu for a send scan? So for the help menu, we'll just specify Nmap and then --help. What is the first switch listed in the help menu? So if we scroll up, let me move this over here. We'll go up to the syn scan. It's going to be -S capital S. Perfect. Which switch would you use to scan? Which switch would you use for the UDP scan? So over here in the help scan, we can see -S capital U. That'll be the UDP scan. If you wanted to detect which operating system the target is running on, which switch would you use? So we'll quickly scroll down here for service version detection, script scan, and OS detection. So -O will enable OS detection. Nmap provides a switch to detect the version of the services running on the target. Scroll up to service version detection, we'll see that is -S capital V. The default output provided by Nmap often does not provide enough information for a pen tester. How would you increase the verbosity? So if you scroll down here, we can increase verbosity. We can increase verbosity by specifying -V or -VV for a greater effect. So -V. Verbosity level 1 is good, but verbosity level 2 is better. How would you set the verbosity level to 2? As we can see, we'll just do 2 Vs instead of 1. We should always save the output of our scans. This means that we only need to run the scan once and gives us a reference to use when writing reports for clients. So that'll be the -O capital A, which is going to output in 3 major formats at once. -O capital A. Which switch would you use to save the Nmap result in a normal format? So these are the different outputs that -OA will save in. The normal output will be -O capital N. A very useful output format. How would you save results in a greppable format? So that'll be the -O capital G. G stands for greppable. So -O capital G. Sometimes the results we're getting just aren't enough. If we don't care how loud we are, we can enable aggressive mode. This is a shorthand switch that activates service detection, operating system detection, a trace route, and common script scanning. How would you activate this setting? So as we can see, that'll be -A down here in the miscellaneous, -A. So we'll go ahead and do that. Nmap offers 5 levels of timing templates. They're essentially used to increase the speed your scans run at. Be careful though, higher speeds are noisier and can occur errors. So if we scroll up a little bit, so up here in timing and performance, we'll see the -T option with 0 to 5. Set timing template, so the higher we go, the faster. So 0 is the slowest, and then 5 is the fastest that we can set our scans to run at. How would you set the timing template to level 5? So we'll do -T5. We can also choose which ports to scan. How would you tell Nmap to scan only port 80? So going up here in the port specification and scan order, we can see the -P option over here. This switch will only scan specified ports. So you'll do a -P and then 80. How would you tell Nmap to scan ports 1000 to 1500? So you'll do -P 1000 to 1500, just like that. You'll basically copy it just like this with the hyphen. A very useful option that should not be ignored. How would you tell Nmap to scan all ports? You'll do a -P- to scan all ports. So that dash after the P will specify all 65,000 ports. How would you activate a script from the Nmap scripting library? So if we go over here, we'll go to script scan. The -- script is a comma separated list of directories, script files, or script categories. So we'll just do a -- script. How would you activate all scripts in the vuln category? So we'll do it -- script equals and then vuln. Since vuln is its own category, we're specifying, which we can just do with -- script equals vuln, since vuln is its own category. So -- script equals vuln. On to task number 4, scan types overview. When port scanning with Nmap, there are 3 basic scan types. There's the -S_T, which is the TCP connect scan, the -S_S, which is the SYN half open scans, and then -S_U, which is the UDP scans. Additionally, there are several less common port scan types, some of which we will also cover. There's -S_N, which is TCP null scans, then -S_F, TCP fin scans, and then -S_X, which is the TCP Xmas scans. So we'll go ahead and hit complete. On to task number 5, TCP connect scans. So to understand how TCP connect scans work, the -S_T option, it's important that you're comfortable with the TCP three-way handshake. So to break it down simply, basically the client will send over a SYN packet. The server will acknowledge that by sending back a SYN ACK packet to the client. Therefore, the client will then reply with an ACK packet to acknowledge that it received the SYN ACK from the server, as we can tell here. We can also run Wireshark to capture it live in our network. So this is one of the fundamental principles of TCP/IP networking, but how does it relate to Nmap? So Nmap suggests a TCP connect scan works by performing the three-way handshake, which each target port in turn. In other words, Nmap tries to connect to each specified TCP port. It determines whether the service is open by the response that it receives. So if the connection does not exist, meaning closed, then a reset is sent in response. So if Nmap sends a TCP request with the SYN flag set to a closed port, the target will then respond with the TCP packet with the RST or reset flag set. So as we can tell here, the client sends a SYN packet to the target responds with a reset or RST packet. If, however, the request is sent to an open port, the target will respond with a TCP packet with the SYN ACK flag set, as we can see up here. So the port on the server is open, so the server responds with the SYN ACK packet, and then the client acknowledges it by sending back an ACK packet to the server. But here we can tell that the client tries to connect to the target port with the SYN packet, but that target port is closed, so the target sends back a reset packet showing that it's closed. So another possibility is, what if the port is open but it's hidden behind a firewall? Many firewalls are configured to drop incoming packets. Nmap sends a TCP SYN request and then receives nothing back. So this indicates that the port is being protected by a firewall, and thus the port is considered to be filtered. So on your Nmap output, you'll see filtered instead of open or closed. On to the questions. Which RFC defines the appropriate behavior for the TCP protocol? That'll be RFC 793. If a port is closed, what flag should the server send back to indicate this? So if the port is closed, as discussed earlier, it'll send back a RST flag set or reset. On to task number 6. So SYN scans. As with TCP scans, SYN scans or -S are used to scan the TCP port range of targets of a target or targets. However, the two scan types work kind of differently. SYN scans are referred to as half-open scans or stealth scans. You'll use the -S for when you're trying to be a little bit more stealthier. Where TCP scans perform a full three-way handshake with the target, SYN scans send back a reset or RST TCP packet after receiving the SYN ACK from the server. This prevents the server from repeatedly trying to make the request. In other words, the sequence for scanning an open port looks like this. So client will send a SYN packet to the target responds with the SYN ACK, and then the client responds with the reset. And so that way it just closes the connection there. And then we can see it here in the example Wireshark output. So this has a variety of advantages for hackers. To break it down, SYN scans are often referred to as stealth scans. due to not being logged by applications and bypassing older IDS systems or intrusion detection systems. They're also faster than a standard TCP Connect scan, as there is no need to complete a three-way handshake. There are also a couple of disadvantages of 2SYN scans. Namely, they require pseudo permissions, and then their second bullet point, unstable services are sometimes brought down by SYN scans, which could prove problematic if a client has provided a production environment for test. All in all, the pros outweigh the cons for reasons SYN scans are the default scans used by Nmap, if run with pseudo permissions, of course. If run without pseudo permissions, Nmap defaults to the TCP Connect scan that we saw in the previous task. When using SYN scan to identify closed and filtered ports, the exact same rules as the TCP Connect scan apply. If a port is closed, then the server responds with a reset TCP packet or RST. If a port is filtered by a firewall, the TCP SYN packet is either dropped or spoofed with the TCP reset packet as well. In regards to two scans are identical, the big difference is how they handle open ports. As we can see here, SYN scans can also be made to work by giving Nmap the cap, net, raw, cap, net admin, and cap, net bind service capabilities. However, this may not allow many of the NSE scripts or Nmap scripting engine scripts to run properly. There are two other names for a SYN scan. What are they? Half open and stealth. Half open and then stealth. Can Nmap use a SYN scan without pseudo permissions? No. On to the next task. Unlike TCP, UDP connections are stateless, meaning that there's no three-way handshake. UDP connections rely on sending packets to a target and essentially hoping that they make it. So like streaming platforms will use UDP instead of TCP. When a packet is sent to an open UDP port, there should be no response. When this happens, Nmap refers to the port as being open pipe filtered. In other words, it suspects that the port is open, but it could be firewalled. If it gets a UDP response, which is very unusual, then the port is marked as open. More commonly, there is no response, in which case the request is sent a second time as a double check. If there's still no response, then the port is marked as open pipe filtered, and Nmap moves on. When a packet is sent to a closed UDP port, the target should respond with an ICMP or ping packet containing a message with the port containing a message that the port is unreachable. This clearly identifies closed ports, which Nmap marks and then moves on. Due to this difficulty in identifying whether a UDP port is actually open, UDP scans tend to be incredibly slow in comparison to various TCP scans. Also, to run a UDP scan, you require pseudo privileges. If a UDP port doesn't respond to an Nmap scan, what will this be marked as? Open pipe filtered. When a UDP port is closed, by convention the target should send back a port unreachable message. Which protocol would it use to send this? It'll use ICMP. Task number 8. Null, fin, and Xmas scans. Null, fin, and Xmas TCP port scans are less commonly used than any of the others that we've covered already, so we're not going to go in such depth to cover the three. So all three of these are interlinked and are used primarily as they tend to be even stealthier, relatively speaking, than a SYN stealth scan beginning with null sessions. So null sessions, or -S are when TCP request is sent with no flag set at all. So as per the RFC, the target host should respond with a reset packet if the port is closed, as we see here. Fin scans, or -S work in almost identical fashion. However, instead of sending a completely empty packet, like the null over here sends none, a request is sent with the fin flag, usually used to gracefully close an active connection. Once again, Nmap expects a reset packet if the port is closed. So as we can see here in the Wireshark output, a fin packet is sent, and then it is responded. The server responds with a reset ACK. Now the Xmas scan, or -S sends a malformed TCP packet and expects a reset response for closed ports. It's referred to as an Xmas scan. The flags that it sets: PSH, URG, and fin. Push, urgent, and fin. give it the appearance of a blinking Christmas tree when viewed as a packet capture in Wireshark. So to break this down, if a port is open or protected by a firewall, Null, Fin, and Xmas scans will identify it as open filtered, closed, or filtered. Responses to malformed TCP packets may vary, and RFC 793 mandates a reset or RST for closed ports and no response for open ports. But Windows and Cisco devices may respond with a reset or RST for all ports regardless. Firewall evasion can be achieved by sending requests without the send flag, but modern IDS solutions are savvy to these scan types, so you'll probably be detected, regardless if you use the -S capital S. Which of the three shown scan types uses the URG flag? That'll be the Xmas. Why are Null, Fin, and Xmas scans generally used? They're used mainly for firewall evasion. Which OS may respond to a Null, Fin, or Xmas scan with a reset for every port? So Windows. So Microsoft Windows. On to task number 9, ICMP network scanning. On first connection to a target network in a black box assignment, our first objective is to obtain a map of the network structure, or in other words, we want to see which IP addresses contain active hosts and which do not. One way to do this is to perform a ping sweep. This is exactly as the name suggests, as Nmap sends an ICMP packet to each possible IP address for the specified network. When it receives a response, it marks the IP address that responded as being alive for reasons we'll see in a later task. This is not always accurate, however, it can provide something of a baseline and thus worth covering. To perform a ping sweep, we'll use the -SN switch in conjunction with the IP ranges specified by either the hyphen or CIDR notation. The -SN switch tells Nmap not to scan any ports, forcing it to rely primarily on ICMP echo packets to identify targets. In addition to the ICMP echo request, the -SN switch will also cause Nmap to send a TCP send packet to port 443 of the target, as well as a TCP ACK or TCP send, if not run as root, packet to port 80. How would you perform a ping sweep on the 172.16.x.x network using Nmap? So you'll do Nmap. So you'll do Nmap-SN 172.16-0-0/16. On to task number 10. NSE Script overview, or the Nmap scripting engine, which is an incredibly powerful addition to Nmap. It extends its functionality. NSE scripts are written in the Lua programming language and can be used to do a variety of things, from scanning for vulnerabilities to automating exploits for those vulnerabilities. So NSE is particularly used for reconnaissance. There are many categories available. Some categories include safe, which won't affect the target, intrusive, which is not safe and will likely affect the target, vuln, which will scan for vulnerabilities that we covered previously, exploit, which attempts to exploit a vulnerability identified, auth attempts to bypass authentication for running services, brute attempts to brute force credentials for running services, and then discovery, which attempts to query running services for further information about the network and scope. In the next task, we'll look at how to interact with the NSE and make use of scripts in these categories. So what language are NSE scripts written in? Lua. Which category scripts would be a very bad idea to run in a production environment? That'll be intrusive. On to task number 11, working with the NSE. In task number 3, we briefly looked at the --script switch for the vuln category using --script equals vuln. It should come as no surprise that other categories work in exactly the same way. If the command --script equals safe is run, it'll run the safe scripts against the target. Multiple scripts can be run simultaneously in this fashion by separating them by a comma, as shown here. smb-enum-users, comma, smb-enum-shares. So that way it'll enumerate smb users and then smb shares. Some scripts require arguments. So they can be given with the --script -args. For an example with this would be the HTTP put script, which will upload files using the put method. This makes two arguments, the URL to upload the file and the file's location on the disk, as shown here. Note that the arguments are separated by commas, as we can see here. These are two different arguments separated by commas, uploading the shell PHPs. A full list of scripts and their corresponding arguments can be found in this hyperlink. Nmap scripts come with built-in help menus, which can be accessed by using the nmap -script -help in the script name. So nmap -script -help, and then the script, for example. And this just prints the menu for the vuln category. What optional arguments can the ftp-anon.nse take? So the ftp-anon.nse can take the max list. On to task number 12, searching for scripts. So we know how to use scripts in Nmap, but we don't yet know how to find these scripts. We have two options for this. We can either visit the Nmap website, or we can take a look in the user share Nmap scripts directory, which is where all the NSE scripts are stored by default. There are two ways to search for installed scripts. One is by using the script.db file, despite the extension. This isn't actually a database so much as a formatted text file containing file names and categories for each available script. We'll navigate to the user share nmap scripts directory, do a quick ls, and we'll see all the NSE files in here. Nmap uses these files to keep track of scripts for the scripting engine. However, we can also grep through it to look for scripts. So for example, we can do grep ftp, and then script.db. And it'll show all the FTP scripts. The second way to search for scripts is to use the ls command, which we can just copy and paste the command nmap scripts, and then FTP, and then FTP and asterisks, and it'll show all the FTP scripts. The same technique can also be used to search for categories of scripts. For example, grep safe, and then the script.db file, and it'll show all the safe scripts. Installing scripts, you can do it this way. Search for SMB scripts in the user share nmap scripts directory using either the demonstrated methods. Do grep SMB and then script.db. What is the file name of the script which determines the underlying OS of the SMB server? If you quickly scroll up, you'll see OS discovery up here. You just copy this over. Read through the script. What does it depend on? This will be the smb-brute. On to task number 13. On the firewall evasion task, we have already seen techniques to bypass firewall using Null, stealth scans, FIN, and Xmas scans. Windows host default firewall blocks ICMP packets, making the ping and Nmap to not detect a target. To bypass this, we'll use the -P n option to treat the target as alive, but it could take longer to scan. ARP requests can also be used if on the local network. Which simple protocols often blocked, requiring the use of the -P n option, or just -pn ICMP. Which Nmap switch allows you to append an arbitrary length of random data to the end of packets, --data-length. On to task number 14. Does the target, the IP, which is the IP here, respond to ICMP ping? Let's go ahead and ping the target. As we can see, it does not. So we'll go ahead and do perform an Xmas scan on the first 999 ports of the target. How many ports are shown to be open or filtered? So we'll just do a sudo nmap -pn for no host discovery, -s capital X, and then we'll specify port 12999 on the target 10.10.139.119. Then we'll go ahead and enter my password. This might take a second. Okay, now that we got our results, how many ports are shown to be open or filtered? It says 999 open filtered TCP ports, so 999. There is a reason given for this -- what is it? The answer will be in your scan results. Think carefully about which switches to use -- and read the hint before asking for help. So on this command with the -VV switch enabled, it's good to practice to always increase verbosity in your scan. So we'll go ahead and run the same scan. This time we'll go ahead and specify -VV. So we'll go ahead and let that run. Okay, and our scan finally finished. So all 999 scan ports are in ignored states, not shown. 999 ports are open, filtered, and no response. So we'll go ahead and say that the -- is because of the no response. Perform a TCP SYN scan on the first 5,000 ports of the target. How many ports are shown to be open? I'm going to run sudo nmap -P -ss-p to specify the first 5,000 ports, and then we'll go ahead and put target IP 10.139.119 and then hit enter. We'll go ahead and let this run its course. All right, so the scan finished. Looks like we have 1, 2, 3, 4, 5 open ports. Open Wireshark and perform a TCP connect scan against port 80 on the target, monitoring the results. Make sure you understand what's going on. So let's go ahead and run Wireshark. So we'll go ahead and start the listener on our Tunnel 0 adapter. So just double click it. And then you'll want to open up your terminal. We'll go ahead and clear this out. We'll do nmap -S for the TCP connect scan against our target at 10.10.139.119. But first we'll want to specify port 80. So we'll go ahead and do -P and then 80 for port 80 and hit enter. Go ahead and stop your Wireshark session. And then over here we can see a TCP connect scan. So the client, or us, the Kali host at 12.138 sent a SYN packet to the target server, which is 139.119, and then the server .119 replied to us .138 with a SYN ACK, and then we responded back. As you can see, .138 responded back to 119 with an ACK packet. So SYN, the client sends a SYN, the target responds with the SYN ACK, and then we sent back an ACK to acknowledge the connection. And after that, there's a reset ACK packet. So go ahead and X that out. Go ahead and just quit without saving. And then we can hit complete. Deploy the FTP-NL script against the box. Can Nmap log in successfully to the FTP server on port 21? So we'll go ahead and clear this. Nmap -script equals FTP-NL on port 21. And then we'll go ahead and specify the IP 10.10.139.119. Hit enter. We'll give this a second to run. And as you can see from the result, anonymous FTP login is allowed. So we can successfully log in. And then task number 15 is just a conclusion saying that we completed the room. There are lots of other resources out there, and we can go to this docs hyperlink to further study Nmap if we wanted to. And we can just hit complete, and that is the end of the room. Hope you all enjoyed, and off to the next room.